Dear students, let's start lecture number 19 on the topic Data Encryption Standard Algorithm, which is normally called DES, and this is part number 4. As you know that we have already covered DES 3 parts, so this is the last part of data encryption standard. So let's get started with the outline. So first we will be revising data encryption standard part 3, which was our previous lecture, and then we will start our today's lecture, data encryption standard part 4. And in this lecture we will be covering some more properties of DES, like data decryption. As you know that we have covered covered DS almost in three parts, but we didn't discuss decryption. We were only talking about encryption. So today we will be discussing about data decryption, the strength of DES, different variations of data encryption standards which are available in the market. Then we have double DES, so as name suggests that performing DES twice with two different keys. Triple DES, so triple DES, so DES will be applied thrice with three different keys. And there is another variation of triple DES that uses two keys. And then I'll be giving you assignment, and we will be discussing sources which I have collected for making these slides, and then we will be having a question answer session. So you can ask me a question if you have any problem. So you can ask me through KCMS or WhatsApp. So just for the brief introduction of, you can see on the right side, we have a DES round 1 explanation. As I mentioned, that if you understand round number 1, so the remaining rounds, as you know that we have total 16 rounds in DES. So if you understand round number 1, so this is very easy for you to understand the next rounds as well. So in a plain text, first of all, you will pass 64 bits, and then it will be passed to initial permutation, as permutation means jugglery of bit position, and then your passed stream of bits will be divided into left half and right half, and then it will pass to the round one where the key transformation transform it and then expansion and permutation is done on it, as we have discussed in our previous lecture. If you have any problem, you can go through those lecture and sort it out. And then the output of expansion permutation, as is name indicate, expansion. So we were expanding 32 bit to 48 bits, and then the permutation is performed, and the output of this will be sent to the X box substitution, and then this is the output of S box substitution will pass to the P box permutation and XOR swap operation, which we covered in the lecture number 3. So today we will discussing P box permutation, XOR operation and swap operation as well. And with that, we will be studying a new topic, which is part number 4 of data encryption standard. So let's start with the revision of lecture number 8, data encryption standard part 3. So as I mentioned, that we have covered all the steps of round 1. So today we will be covering P box permutation. We have covered this as well, but if you have any problem, so I am revising my previous lecture again. So in P box permutation, the output of X box consists of 32 bits. They are permuted using a P box. This involves simple permutation, swapping of each bit with another bit without any expansion or compression. This is called P box permutation, and this is explained with the help of this diagram. You have passed 32-bit input block where each bit is replaced with some other bit, like one is replaced with sixth one, and fourth is replaced with second one, and second is replaced with third one, and so on. So finally you get the permuted output in 32-bit, which is passed to XOR and swap level. So when it receives that all the operations are, all those operations are performed only on 32-bit. As you know that 32 bits are received here, so since 32 bits are passed to XOR and swap operation. So only 32 bits of right side portion of the 64-bit original plain text on the right plain text. The left half portion, left plain text, was untouched. This is, as you know, I hope that you understand fiscal block structure on which this DES based on. So in that, this thing is brought from the fiscal block structure. So in the fiscal block structure, the left portion was untouched, if you remember. The left plain text is now XORed with the output produced by the P-box permutation. The result of this XOR operation becomes the new right half, right plain text. The old right half, right plain text becomes the new left half. This is a process of swapping. So the left half will be converted into right, and right will be converted into left. I explained that with the help of example. So here 32-bit left plain text and 32-bit right plain text. So here you can see that after performing all those operations of round 1, XOR operation will be performed on the left side, and this will becomes your right side, right plain text, and the right side plain text will be passed to left plain text. So this is how the swapping is performed, and after the swapping, the result will be passed on to the next round, where the same operation will be done with the different sub key provided. So you will get the outcome and pass to the next round. So by passing each round, you will finally you will reaches to 16th round. So after you cover all the 16 rounds, final permutation is performed. This is performed once, like initial permutation and final permutation. This is performed at the end of all the rounds. So initial permutation is performed at before first round, and the final permutation is performed after 16th round. As you know, the DS is based on total 16 rounds. This is simple transposition. For example, the 40th input bit takes the position of the first input block for input bit, and so on. You can see here with the help of a diagram, the output of the final permutation is the 64-bit encrypted block. So each bit is replaced with some other bit position. So this is how you may call it as a permutation. So the jugglery of bit position is done here. So you will get the outcome of output of 32-bit. This is general structure. As you know that as I mentioned, that initial permutation and final permutation, this is out of the rounds. Like before first round, you will perform initial permutation, and after 16th round, you perform final permutation. And rest of the structure is as you have passed 64-bit, but as first and the 8-bit of each byte will be used for the parity checking. So it was left with 56-bit, and when it passed to the round key generator, you will get 48-bit subkey. So you will be receiving 48 bit sub 48 bit sub keys for each round. So each round will be having unique 48-bit key. So after final permutation, you will get 64-bit ciphertext. So now you have a plain text and now you have a ciphertext. This means the encryption has been done. So then it will pass to the receiver side. Let's start lecture number 19, data encryption standard part 4, which is our today's topic. Some more properties of DES, like data decryption. As I mentioned before, that we didn't discuss data decryption. We were only discussing data encryption. So for if you remember from the cryptography, that in the as DES is based on symmetric encryption. So as in the symmetric encryption, same key is used on the both sides, sender side and receiver side. But on the receiver side, it will be performed in reverse order. So similarly, in the DES, as the DES is also symmetric encryption, based on a symmetric encryption standard. So the same algorithm will be applied, but in reverse order. The only difference is reversal of key positions. Like if the original key is divided into K1, K, and these are the subkeys of K. Then if these are performed for the encryption of each round, then for the decryption, they should be applied K16, K15, and so on. Finally, you will apply K1 to get the plain text back. So now the strength of DES. The inner working of DES is known to general public as I am explaining all these steps, but it doesn't mean that you can easily decrypt you can easily decrypt the value encrypted by the DES, because the strength of DES lies in its keys. As I mentioned, that you have 16 different subkeys. So this is very difficult for the attacker or intruder to predict that. And DS uses 56-bit key, as everybody knows. I mentioned this before. So these are the possible number of subkeys which can be generated. So you can guess from this number that if someone attacker or intruder applies brute force attack, so this will be impractical for him to get the value which is encrypted by DES. Now, variation of DES. So we have double DES, performing DES twice, as the name suggests. So DES will be performed twice with two different keys, and triple DES. So triple DES that uses 3 keys, and triple DES that uses 2 keys. Now, double DES. In double DES, does twice what DES normally does once. So as name suggests, so you will be applying DES twice. This means that 32 different subkeys will be applied to making your document encrypted. Double DES uses two keys. It performs DES on original plain text, uses K1 to get encrypted data. It again performs DES on the encrypted data, but this time with other key, K2. The final output in the encryption text, the original plain text encrypted twice with 2 different keys as you have encryption. So DES will be applied here and DS will be applied here. So if K1 is the key, so you will be getting 16 sub keys out of this K1 and 16 sub keys out of this K2. So you will be having 32 total keys which will be applied on the document to be encrypted. So you can guess that how difficult it would be for the intruder or for the attacker to decrypt that value. Now, triple DES with three keys. The idea of the DES with three keys, the plain text block P is first encrypted with a key K1, then encrypted data with a second key K2, and finally a third key K3, where K1, K2 are all different from each other. So here you have original text, then DES will be performed. So this you will get the cipher text, and then you will apply DES again with a different key K2. So this will again you will receive a cipher text. Again you will apply DES now with this time with the different key K3, and you will finally you will get your ciphertext. So you can guess that for as DES is based on 16 rounds. So you have 16 rounds here, 16 subkeys here, 16 subkeys on the second round, and the 16 subkeys for the third round. So total you have 48 subkeys. So you can guess that how difficult or how what is the level, what would be the level of security. Your document would be more secure, and intruder has no chance to get your plain text back. So triple DES with two keys. Triple DES the plain text with key one. Thus we have plain text of encryption with key K1 of plain text, decrypt the output of the step 1 with K2. Thus we have decryption of K2 and encryption of K1 of the plain text. Finally, encrypt the output of step 2 again with K1. Thus we have encryption of K1 and decryption with the help of K2, encryption with the help of K1 of plain text. So this is called encrypt decrypt or DE mode. So here you can see that you have original text, you apply this by using this K1. Here the DS will be applied and you will get the ciphertext, and then DS will be applied again but with a different key. So you will get the ciphertext, and then you will you apply the same key like K1 to get the ciphertext. So here you have two keys like K1 and K1. This is same. So one key is here and one key is this one. So you have total two keys for protecting your documents. I think now you can guess this, that if you are applying more keys or a more DES on that, so you can make you are making your data more secure. But on the other hand, if you are proposing this solution for the wireless devices or handheld devices or the devices which for the devices those have resource constraints. So so this mechanism will not be applied there, because they will consume a lot of computation and energy there. So you will so on the one hand you are making your data more secure, but on the other hand you are getting inefficiency of the system as well, because system will take more time to convert your original text to ciphertext. Now, with that, we reaches to assignment. So, submit a solved example of single, double, and triple DES. Moreover, you make a comparison table between these different variations, that which mechanism applied and what would be the consequences. So you discuss all these three in comparison and submit through KCMS. These are the sources which I have used for making these slides. So you can go through those references for getting more knowledge about this topic. or if you have any confusion in understanding, so you can explore these references. So if you have any question, you can ask me through KCMS or WhatsApp, or you can email me. My email address is listed at the end, so I'll be more than happy to answer your questions. Uh, Thank you. With that, we reach to end of this lecture. So till next lecture, Allah Hafiz.